Hi everyone, we are looking at our exponent rules or our laws of exponents. The front page of these notes are actually all in the slides, and so if you click through the slides you can see what to write down in each box because the actual rule hasn't changed since you learned it years ago. So you might know what to put in these boxes already. What I want to do is actually go through some of the examples. So we're going to go to the next page. And we're going to skip around a little bit because I want to make sure I get some basic examples as well as some more complicated examples. So when we start up at the top here, if we have something that looks like this, then I know if I'm multiplying my two terms that have the same base, I want to add my exponents. So I add those and I would get y to the 15th. And that's it. That's all I can simplify. When I move on to the next one, I notice that I have some parentheses with an exponent on the outside. So this too has power over everything inside the parentheses because that's what it's connected to. So it has power over our coefficient as well as our x cubed. So I can rewrite this as 2 squared and then x cubed squared. So to show that both of them now have an exponent of 2. When I simplify this, 2 squared is 4, so that's going to be my new coefficient. If I have a power raised to another power, I want to multiply my exponents. 6 times 2. 3 times 2 is 6. So I would have 4x to the 6th, and this is as simplified as I can get it. The third one, I noticed that I have the same base for all of them, and so I want to add all of my exponents. So negative 2 plus negative 6 is negative 8. Negative 8 plus 4 is negative 4. So I have x to the negative 4th. Now, I'm not done because I never leave a negative exponent in my simplified answer. So I can rewrite this as 1 over x to the 4th. Because if it's a negative exponent, I have to move it. And so right now, technically, I'm going to use a different color here. Technically, it is over 1. And so I want to move this into my denominator because that's not where it was. And then when I move it to my denominator, my exponent turns positive. I have an invisible 1 in front of this, and that's what this one is. If my negative exponent was already in the denominator, I would have to move it to my numerator. All right, I'm going to put a box around that one. And then the last one in this row, I notice that I have x's for all of them. And I have a 0 exponent. So I like to start with finding my 0 exponents first. And I cross them out because I know anything raised to a power of 0 is 1. Well, 8x to the 8th times this turns to 1 would still just be x to the 8th. So I can cross that out. Now that I have a fraction, I want to use my quotient rule. And so I'm going to do my top exponent minus my bottom exponent, and that would give me x to the negative 4th. And then again, I can't leave a negative exponent in my simplified answer, so I want to change that to 1 over x to the positive 4th. Another way we can think about this one, since we have a fraction, I know I have 8 x's in my numerator and 12 in my denominator. You wouldn't have to write this all out if you don't want to, but it's a way that you can think about this problem. One, two, three, 4, 5, 6, 7, 8. Okay, so I technically have 8 x's in my numerator and 12 in my denominator. So when I simplify it, I know that I can cross off 1 for my numerator and 1 for my denominator. They will cancel each other out. And I can keep doing that until I can no longer cancel some out. So I can cancel this one out, this one, this one. And then after that, I can't cancel any more out because I have none left in my numerator. So I notice I have 1, 2, 3, 4 left over in my denominator, which is why my answer is 1 over x to the fourth. So if you want to do it like this and then change it, or just know, well, if I have 8 in my numerator and 12 in my denominator, my answer will have more in my denominator at the end from that picture. All right, so now we're going to kind of skip around here. So looking at these ones, you'll notice that we have lots of different things that we can do to simplify it. So if we're using multiple exponent rules, there's a typical order that I like to do. So I always like to start with, do I have any zero exponents? Because if I do, I can get rid of that and make it simpler and less daunting to look at. So that's the first thing I'm going to do. So I'm actually going to write that on the side here. So my first thing is to do my zero rule. Then, after I take care of that, I want to look for parentheses. If I have parentheses with an exponent on the outside, so a power raised to another power, I want to get rid of parentheses right away so that I can then simplify what I have left. So this is what I always start with whenever I solve a more complicated problem. So we're going to skip this row here and move on to this one. So we're starting to get into a little bit more complex. I don't have any zero exponents, okay? So I'm going to get rid of my parentheses. So this exponent 2 has power over my x squared as well as my negative 3 because it has power over everything inside the parentheses, and that is what's inside that parentheses. For my second one, I have this exponent and it has power over my 2 as well as my x squared. So when I simplify this, I'm going to write negative 3 inside parentheses with my exponent on the outside. The reason I do this is because if I type this into my calculator versus without parentheses, it'll give me different answers. So negative 3 squared, let's see here, is 9. Now if I do it without parentheses, I get negative 9. So with the bottom one here, what it's actually doing is it's squaring just the 3 and then attaching the negative on at the end. This one is squaring the negative 3, and I want to actually square the negative 3, so that's why I want to keep my parentheses. Then I have x squared raised to another power of 2. I want to multiply those exponents, and so I would get x to the fourth. For my second set of parentheses, I have 2 raised to a power of 3. Because it's a positive number, the parentheses aren't necessary, but I'm still going to do it so that it becomes a habit. And then x to the negative second, and I'm raising that to a power of 3, so I want to multiply those exponents. So I get x to the negative sixth. There's a couple different things we can do next to simplify it. What I'm going to do is take care of my coefficients. Well, negative 3 raised to a power of 2, we did that in the calculator, and that was 9. So I'm going to change that to 9. I'm going to keep my x to the fourth. 2 to the power of 3 is not 6. It is 2 times itself 3 times, so 2 times 2 times 2, which is 8. I'm just going to put a multiplication dot there, and then I still have x to the negative sixth. If you can combine multiple steps into one, absolutely do it. So now I want to multiply my coefficients 9 times 8, and when I do that, I get 72. Then, because these are both x's, I know I can add my exponents, and I would get x to the negative second. Well, I can't have a negative exponent, and so I know that technically this is like over 1, and so I'm going to take my x to the negative second because that exponent of negative 2 is only connected to my variable x, and I have to move that into my denominator. I realize my pen is not doing so great, but that's okay. Once I do that, I am going to have x to the positive second in my denominator. Let me scoot this up a little bit. Because when I move it, it turns positive. The 72 doesn't move, so it is still in my numerator of my fraction, and I am done. When we look at the one right next to it, I want to start off the same way. So the first thing I look for are zero exponents. I don't see any. Then I look for parentheses. I also don't see any. So there's a couple ways we can do this. We can use our quotient rule and subtract our exponents. Or, because I notice both of these are negative, I know that if I move them into my numerator, they will end up turning positive. So I'm actually going to start with that. So my x to the negative fourth, I'm going to move up to my numerator, and then my y to the negative second, I'm also going to move up to my numerator. When I move those up, they are going to turn positive. So I still have x and y in my numerator from these that were up there to start. Then I am moving up x to the fourth, and it turns to a positive exponent, and y squared, it turns to a positive exponent. In my denominator is still 7 because I haven't moved that at all. Now I can combine my x's and my y's. So this x has an invisible 1 exponent, so when I add my exponents, I would get x to the fifth. And then when I combine my y's, I would get y to the third, because this has an invisible 1 plus 2 gives me 3. And then it is still over 7, and that is as simplified as I can write it, or I can write it as a fraction as 1/7 times x to the fifth, y to the third, because we know that if we are dividing by 7, that's the same as multiplying by the fraction. So either of these would work as your final answer. I want to do one more from the bottom, so let's, well, maybe I'll do two more. We'll do the left one and the right one, because they're different in little ways. So the one on the left, I look for zero exponents. I don't have any, but I do have parentheses, and this exponent 2 has power over everything on the inside. So you'll notice in this fraction, my denominator is included in my parentheses, so I want to pay attention to that because that is important. So I have my coefficient out front. I'm actually going to change my pen and use the black one. So my coefficient 2 is being raised to a power of 2, so I'm going to write that down first. Then y to the fourth is being raised to a power of 2. I use my power rule and I multiply my exponents. In my denominator, I have 4 raised to a power of 2, and then the y is being raised to a power of 2. It was an invisible 1 exponent, so 1 times 2 gives me that 2, and that's how I get this. To simplify this, I want to do my coefficients first. So I know 2 squared is 4, so my numerator changes into 4 y to the 8th, and then 4 squared is 16, and I have y squared. And I want to simplify this separately. So I want to simplify my coefficients because I know that 4 over 16, I can simplify that fraction. I can divide both of them by 4, so I would end up with 1 over 4. Oops, that's not on the screen. Another way you can do it in your calculator is if we type in 4 divided by 16, we get a decimal. If I want to change that back into a fraction, I'm going to hit my math button, which is under my alpha, and I want option 1, which is already at, so I hit enter, and I'm changing my previous answer, so my 0.25 into a fraction, and I get 1 over 4, which is what I got here. So math, enter, enter. Then I'm going to look at my y's here. So if I'm using my quotient rule, I'm going to use my top exponent minus my bottom. So that would be y to the 6th. So again, just like the one we did up here, I can write this two ways. I could say 1/4 times y to the 6th, or I could say y to the 6th over 4. Either one is perfectly acceptable. All right, so the very last one here, so the bottom right on this page, I have a lot of negative exponents. That's the first thing that stands out to me. So I want to be really, really careful when I'm doing this, because if I'm subtracting negative exponents or I'm moving a bunch of things around, it could get really confusing. So I don't have any zero exponents, but I do have parentheses. So this -3 has power over everything. So I want to apply it to everything. So my coefficient here, 2, is going to have a -3 exponent on it because it has power over this. It also has power over the x, so I multiply my exponents together. -1 times -3 turns into a +3. Then that exponent has power over the y in the numerator, so that would be y to the -3 because it's a +1 that's invisible times -3. Then for my denominator, my exponent has power over my x, so again I'm multiplying those exponents. I'm going to get x to the 9th. And then it also has power over the y, so I multiply those exponents and I get y to the +6th. So now I'm going to do two things in the same step. I'm going to simplify this, and I'm going to move that one. So I notice that they are both negative exponents, so I have to move them into my denominator. When I move them into my denominator, then the exponents turn positive. So I'm going to write it down here. 2 to the +3rd is in my denominator, but since I know 2 to the 3rd is 8, I'm just going to write 8 in my denominator. Okay, so what I'm actually going to do is I'm going to cross it off once I write it down here so I know I have everything. Then I have x to the 3rd in my numerator, so I'm going to keep that in my numerator. Wrote that down so I can cross it off. My y to the -3rd, we're moving into our denominator, so I'm going to move it at the end here. When I move it, it turns to a +3. And then what I have in my denominator is actually going to stay in my denominator, so x to the 9th, I'm going to cross that out, and then y to the 6th, and I can cross that out. So when I simplify this, I have two things I can simplify. I can simplify my x's, and I can simplify my y's, and I am running out of room, so I'm going to do it in the same step. When I simplify my x's, I want to subtract my exponents. So top minus the bottom, 3 minus 9. That would give me -6. Now if it's a -6, that means I have to move it into my denominator. I also know that since 9 is bigger in my denominator, my final answer will end up in my denominator. So I would no longer have anything in my numerator. So my numerator is just 1. I still have this 8 in my denominator. I now have x to the 6th, which came from this part, these. And then for my y's, I want to add my exponents. And 6 plus 3 is 9, so I get y to the 9th. And this is my final answer. I cannot simplify it any further. I hope going through a couple examples is helping.